Okay, hi everyone. Welcome everybody that's in the room and at home. Hello. So I think I sound very loud today. I might turn that down a little bit. I don't know if that's any better. Okay, so today we're going to do a little bit of a recap on arrays and functions with arrays. We're also going to look at arrays of structs, and then we're going to look at 2D arrays. Okay, but a few announcements first. So this Thursday the 13th of March by 11:59 p.m. This is the census date. Oh, I've written census data. That's a very different thing. The census date, it's this Thursday. This is when you can drop a course without any financial liability, so you don't have to pay for it. You don't get a fail on your academic record or anything else. So for any of your courses that you're doing right now, you know, if you're considering dropping the course, and I'm not suggesting you should be, this is the date, so we just make sure everybody knows about it. Okay, but for all courses, T1 courses. All right, assignment 1's going to be released today after this lecture at 1 p.m. I'm not going to give any spoilers away here, except it's going to be due Monday week 7 at 5 p.m. It's an individual assignment, not pair programming or, you know, group assignment. And basically you're going to be doing stuff with arrays, two-dimensional arrays, which we're going to look at today. You know, using functions. You'll be practicing debugging for sure. You'll be practicing your skills of patience as well as you're looking for your bugs. And there'll be a mark for style. So we'll do auto tests like we do with the labs, and auto marking like we do with the labs. But there'll also be 20% of style. So your tutor will be looking through it and checking, oh, what's that? Is that thunder? Checking that there's checking that you've done your indentation and your comments and everything else we talk about with style. But you'll find out more about it all this afternoon, and I'm sure we'll be discussing it more in lectures and stuff. So that's a heads up. Go look at it after this. Revision sessions. So the first revision sessions are on today and Thursday. So you do have to book for them or sign up. So sign up, there's a link here, but you can find all this information as well on the forum. So if you're interested in going to a revision session, sign up. There's one today, 2 to 4. With the revision sessions, has anyone been to any of the help sessions? Okay, I'll talk about them in a minute. So revision sessions are kind of structured. There are set topics that, you know, there's somebody leading. It's a bit like a class /lab. So that's what that is. There are also help sessions. There's a whole schedule full of them here. These are drop-in classes. These are where you sort of control what you want to ask. You turn up and you can ask the tutor there for some help with something. So, you know, one's more of a formal-ish type class, and this is just go and get help with what you want. You don't have to book these. I will warn you though, when it gets around the assignment due date, these get very busy. So, you know, get all your questions now. Go, like when you've got questions now, go to the help sessions before they're too full. There's also revision videos. Like there's so many resources here to help you. I've got a link here and the QR code, but these are just very short videos that help you revise important topics. So they're kind of little bite-sized videos. If you want any more topics, let us know. We're going to be adding more videos to this. So go and check out those videos. All right. Any questions about any of that stuff? So last week we covered a lot. We talked about functions, style, and arrays. So you wouldn't have practiced those yet in tutorials or labs. So you've just heard about them probably in lectures. So don't feel overwhelmed and think, oh, I'm not 100% on top of these yet. That's a disaster. No, you're going to be practicing them in the tutes and labs. We'll be revising them a little bit today in the lecture, and you'll just be using them all throughout the term, so you're going to really have a chance to really get on top of these topics. All right? We don't expect that you hear it once and you've mastered it. All right, so we'll do a bit of a recap now. Oh, here's my disclaimer. Yes, sometimes the code that I'm typing live in lectures, I haven't gone back and commented it properly or fixed up every detail. Sometimes I've typed in something to see, you know, to answer a question, just a bit, some dodgy line I've added. So just be aware that might not be the model of style to follow. When you get the assignment, you'll be given some starting C code. So I really recommend looking at the style of that and, you know, following suit with that, looking at the style guide and the 1511 style checker. Okay, so let's get back onto arrays. So we've got this array, which I really regret naming chocolate eating, but anyway, here it is. It's of size 7. The name of the variable is chocolate eating, and it can store 7 integers. And in fact, the integers that I've decided it's going to store are these ones here. So we get a chunk of memory big enough to store 7 integers, and all of these integers are initialized in the array. Now, with arrays, we've only got one variable for this whole chunk of data. So we use indexes. So if I want to access individual elements within this array, I've got to use an index. The indexes start at 0, and they go up to, in this case, 6. Or 1 less than the size. So if I've got an array of size 100, the biggest index will be 99, right? So that's a common mistake, to go beyond an array, and it's only going to cause pain. All right. So yeah, I can, if I wanted to go to chocolate eating at index 2, that would give us this particular value, right? What if I go to chocolate eating at index 5, what do I get? Everybody? On the count of 3? Yeah, 3. Very good. Okay. And what do I get if I go to index 7? Yes, DCC might tell me at compile time and give me a warning, depending on how I'm doing it. Or when I run it, I'll get a runtime error. So we don't want to do that, but we might accidentally at some point. Now, a common thing is that we want to have some sort of way to go and look through all the array or look through specific elements without like hard coding it. So often we loop through these things. This is a very typical thing to do. We call this traversing an array, starting at the beginning element, which is index 0, and going up to the end of the array and making sure we don't, go over the array and go to that index that doesn't exist. So here our loop is going from I equals 0 to I is less than 7. Less than or equals will give you the bug. And at each point, I'm printing out the integer because all of the elements in this particular array are integers. So we can print them all with %d. And we use our index because I at first is set to 0. So it would be printing out the one at index 0. Then as we increment I, would be printing out chocolate eating at index 1 because I is now 1. Then when I is 2, we'd be printing out the next one. I gets incremented to 3. We print that out, 4, so on. Eventually, I is equal to 6. We print this one out. We'll do this increment and I will be equal to 7 and the loop will stop. And we've gone from the beginning to the end of our array and printed them all out. But we can use this pattern for other things. Like we can have that loop and instead of printing it out, we could add up all the numbers in the array, or we could modify them all and add 10 to them or whatever. We can use this sort of pattern with this kind of loop to do something to everything in the array. Are there any questions about this? How are we feeling about these 1D arrays? Okay, all right. So I'm just going to go and show us, remind us all of some of the functions we wrote and then write a few more. So, okay. So the other day we did write code to print out the contents of an array and we just actually did it on the slide. So I've just got this code here, right, which was just what we saw. Up here, I've declared an array called data and I've put some data in it. So let's just see what this program is doing right now. I've declared an array. Oh no, I'm over disk quota. Oh no, hang on. Let me just quickly delete a few things. Has this happened to anybody? If you have too much data on your in your account, you can go over quota. Okay, I'll be 2 seconds. Oh, could you see this online? Okay. Yep, okay. Sorry, just be 1 more second. Okay. All right. Yeah. Don't stop eating files. I don't know what happened there. Okay. So I think we're all back. Sorry for that, guys. Now we've got this. Let's try again to compile this now that I've got room to create the executable. All right. Now we're running it. We've got this particular array. So remember, when I've created this array, I'll just draw it. All right. It's probably not big enough. I've got 4, 6, 7, minus 3, 9. Oh, I never make these quite big enough. And 2. All right, and I've got the indexes 0, 1, 2, 3, 4, and 5. Okay, does that look right? Yeah, so my data size this time is 6. If I've got a size 6 array, I'm going to have indexes from 0 up to 5, and that's what data I've got in it. Okay, so let's just move this over a little bit. Okay, so let's run it. What does it do? Right now, it's just printing out the data in the array because I'm calling the function. So just a reminder of what our functions look like when we've got arrays. Typically, we want to pass in the size of the array because you can't just tell from an array how big it is or how many elements are in there. So we pass in the size, and then we've also got to pass in the array. So down here where we're actually calling this function, we're passing in the size, which is 6, and then we're just passing in the array, and we just use the name of the array, right? We don't have any brackets when we're passing it in or anything like that. We just give the name of the array. All right, any questions about that so far with the function? Okay. All right, now when we're doing read data, I might just move this so I can see the main function and this function at the same time. So instead of hard coding this data in, I could just ask for an empty array of that same size. Let me just empty this out. And I could read the data in. So if I do something like this, I've got an empty array, the values are uninitialized. What's going to happen if I try and print this? Do we know? Let's try. We get runtime uninitialized variable accessed. So we've got uninitialized data here. If we try and use it or print it out, the program's going to crash. Is everyone clear with that? So what we're going to do, since we haven't already filled it with data, we're going to read the data in. And I've got a function to do that. I need to pass in the size of the array, and I need to pass in the array. I just want to go over this sort of detail again. So we learned before that if I pass in some data basically to a function, if it's an integer, it's just going to get a copy. So this would get a copy of the value 6. And size would be its own variable with the number 6 in it. Now when we pass in an array to the function really gets access to this original array. It's not getting a copy. So this means any changes that we make to the array, we're making to that original array. So we can modify the data inside an array from another function. Whereas we can't modify, if we had an integer and we pass that into a function, we can't modify that original integer. So this is something that you'll get used to. I'll say it again and again. But that's why we could read the data into this array that we pass into the function. So when I do this, oh, I haven't saved it. Oh dear. Okay, as I'm entering this data, so I enter the number 9, for example. It's not really printing anything out yet, but what it's doing is, yeah, it's going into this original array and it's filling up the data here. So now I would have a 9 in this position. And my loop in this function is going through again and again and putting all of this data into the array. Okay, so it would have put all of this in. As I typed it in, the scanf would be putting it inside the array, the original array. When this function finishes, we go and call print array and it's going to print out the contents. Okay, so this is how we can actually pass arrays into functions and let those functions modify the contents of the array. All right, so let's just write a couple of new functions. Let's write print odd data. So here's the prototype. Again, we're just passing in the size of the array and the actual array. And I'm sick of typing in input already. Let's comment that out and have the one with the hard-coded data. All right. So let's think about what we want this to print. If I've got this array with this data in it, and I want to print out all the odd ones, I'm going to get, well, I'm not going to get the 4, I'm not going to get the 6, I'm going to get the 7, that's odd. I'm going to get the -3, I hope, that's odd. I'm going to get the 9, I'm not going to get the 2. So this is all we want to do. We want to go through and print out the odd numbers. How are we going to do this? I need a bracket there. Oh, no, I need a semicolon there. Okay. So basically, it's going to be very similar to this print data, right? We're still going to go through every element in the array, but as we go through them one by one, we look at them and we decide whether we want to print them or not. So I look at the first one, it's 4. Do I want to print it or not? How can I tell if I want to print it or not? Yeah, I can use an if statement. And how can I tell with an if statement if something's odd or even?
If the number percent 2 equals to 0, then that's not the odd.
Yeah, so if we do mod 2 with the number and we get 0, that means it's even. What do we get if it's odd? We get, let's try with 1. Let's do it. So in here, oh, not in scanf, that's the wrong function. In here, I'm about to print my piece of data. I want to check if I actually really want to print it. This is the piece of data. If this mod 2 is equal to 1, well, then it's definitely going to be odd. So then I definitely want to print it, right? So if I get 1 when I do mod 2, it's going to definitely be odd. Let's compile it, see what we get. We didn't get 4 and 6, which is good. We got 7, we got 9, we didn't get 2, but what was missing? -3. So if I do mod 2 with a negative number, I actually get -1. So it's not getting picked up here. What are our options? Yep.
You could do the exclamation mark equals 0.
Yeah, so I find the easiest option is just say not equal to 0, right? There's not going to be a -0. If it's even, it's definitely going to be 0. If it's not equal to 0, it's going to be odd. So checking if it's equal to 1 will work for positive odd numbers, but not the negative ones. Okay, let's try this. Okay, that picks up that odd one. All right, we'll do one more. Let's find the maximum in this function, in this array. So I'm going to move it up just so we can see both functions at the same time. Now, if we're trying to systematically find the maximum in an array, how would we go about doing that? So as a person, this is how we might do it as a person. We don't really think we can just sort of scan through and see it. But I could take a look at the first one and I could sort of think, okay, 4. That's the maximum I've seen so far. Let's check the next one. And I check the next one and it's 6. And then I think, well, 6 is bigger than the maximum I've seen so far, which is 4. So actually, 6 is the maximum. And then I look at the next one and I see 7 and I say, well, 7's bigger than the maximum I've seen so far, which was 6. 7 must be the maximum. And then I look at the next one and I think, well, -3 is not bigger than the 7 I just saw. That's not the maximum. I look at the next one, 9's bigger than the 7. So actually now that is the maximum, at least that I've seen so far. I look at the next one, 2's not bigger than the maximum I've seen so far, which is 9. And you know, I've then looked through every single element in the array. Every time I update the maximum, if I find one bigger than I've seen before. And at the end, I know that the maximum was 9. So how do we do this in code? Well, I'm just going to have a variable called max. And I'm going to make it equal to the first element. What have I done wrong? Oh, nothing. Now I'm going to do a while loop. Now typically we do a while loop like this. Or what am I doing? That's not a while loop. Like this. Right, and we put something in here. What are we doing? Well, for every element, we're just checking, is this element I'm looking at right now, is that bigger than the max one, the biggest one I've seen so far? So to start with, we have 4 in there, but as we're looking through, we see the 6. 6 is bigger than 4, so we say, actually, the biggest one I've seen so far is this new one I'm looking at right now. So I update the maximum. Then at the end, when I've gone through all of them, I should have the biggest one left in this variable. So I return that. Oops. And remember, returning is just you're returning a value that the main function can use. So we're basically saying to the main function, yeah, the maximum was 9 or whatever. Let's check that. Now, to check it, I need to actually use it somewhere. So let's just print out the max is actually, I can even just call the function like this. Do we like this or does this confuse us? I can call the function, I pass in the size of the array and the array, it's going to give me back, we know in this case it's giving me back 9, and we're printing that 9 out. Okay. Now when we do functions like this or code like this, we shouldn't really just check it once with one sort of case. Like we should go and create other arrays and check, well, what if the maximum was at the beginning of the array? Does it for some reason not work the way I've coded it? What if the maximum's the last one in the array? Does it still work? What if the maximum's a negative number? Does it still work? We should think about, what if there's only one thing in the array? Does it still work? We should think of all those cases when we test things. I'm not going to do them all now because, you know, we don't have all day. Let's just see if it works. In this case, yeah, the max is 9. All right. Does anyone have any questions about one-dimensional arrays before we move on to arrays of structs? All elements, yeah, the question was, do all elements have to be the same type in an array? Yes. So if you've got an array in integers, yeah, they have to all be integers. Unlike a struct where you can have a char and an int and a double in a struct. So Now this might be confusing then because we're about to do an array of structs. Now in this array of structs, first of all, let's remind ourselves about structs, just quickly. I've designed a struct. In fact, I've designed this one before and shown it to you before, I believe. It's an old favorite. Struct coordinate. Struct coordinate has two members in it. When I do this, this is just like the blueprint. And when I actually, in my program, write struct coordinate, this is like a type. This is a type I've designed. This is like writing int or double. Then I can give it a variable name. I'll call it P, just because I'm writing and my writing's messy. Let's just keep it short. So now, once I've done that, I've got a variable I've called P, and it's given me a chunk of memory for this one struct. Then what I would do, imagine I wanted to set it to have an x of 5. I'd say p.x equals 5, and that would set the member x inside the struct. I would then say p.y equals, whatever I wanted it to be, minus 7. And that's how we use a struct. Does everyone remember this sort of thing? Well, now we can have arrays of structs. And this is really an array of one type though. It's an array of structs. This over here is defining the type of the array. I've got an array that can store struct coordinates. This is giving the name of the variable. It's called map. And this is giving it the size. So now I can have an array of size 5 of structs. And the other principles work the same. If I've got an array of size 5, my indexes go from 0 up to 4. If I want to access any element in the array, I still use an index. So if I wanted to access this here, I would say map at index 2. The only thing is, when I go to map at index 2, what type is there? What do I get? So what's the type of all the data in this? Yeah, I've got an array of structs. If I go to index 2 or any index in this array, I get a whole struct. So that's the first step. So imagine I wanted to set the x coordinate in here to I don't know, 99. I first go to the correct struct within the array. I then would say, okay, I want to set the x value to 99. Does that make sense? So that would put 99 in element 2 in the x member of that struct. If I go to that same element, element 2, and I go to the y member, I can set that to, something else. All right, does that make sense? Does anyone have any questions? And that's what I'm doing here. So we're first going to index 0, gives me the whole struct. Once I've got a struct, I use the .x in this case and .y to set the value in it. All right, we can still use while loops to go through each one of them. We can still, like, all the same things apply. It's just that we've got an array of structs, which does sort of make it a little bit more complicated when you just learnt structs and you're just learning arrays. Okay. So let's have a quick demo of this. Yeah, we've still got time. Okay. So imagine I've got, well here, all I've done so far, let's see what I've done. I've got an array of size 5. No, that won't be big enough. Okay, and these are all structs. That's all I've done. None of them have any values. They've all just got undefined data in them. Now, if I want to read these in, again, I've got 5 elements I want to read in. And I can have a while loop that goes through the whole array like this. And I can use scanf to read them in. But with this, you know, for every element in the array, it's a struct coord. I need to read in 2 integers, an x and a y. Right? So I'm going to read in 2 integers at a time. And I might just print something before I forget. I'll just say enter data. Now, every time I read something in, I need to read it into the data at index I. That's going to take me to the whole struct. But then I need to read it into the relevant field or member. So I would do it like this. Data at index I takes me to the struct. .x takes me to the member. What else do I need to do if I'm doing a scanf? Yeah, I've got to put this in because this is taking me to an int and I need to put that ampersand so scanf will work. I do the same thing for the y member. They're both ints. Oh, it's not called data. Sorry, it's called map, the name of the variable. That's better. Yep, so I take my array, go to index I, go to the x field, or go to the y field, and I read in 2 integers at a time. All right. Now, if I want to see if this works, I probably want to print it out. So I'm going to copy and paste this because a lot of the logic is the same. Oops. Instead of reading stuff in, I'm printing it out. And I don't need to use that ampersand. Okay. I also might want a new line at the end of this so we can read it better. Okay. So let's try this. Oops, wrong file. One more try. I've really done something silly. What have I forgotten to do? I've forgotten to call any of the functions. Just because you make the functions doesn't mean they get magically called. So I need to read in the map data. I need to pass in the size of the array, and I need to pass in the array. Then I want to print it. Okay, let's try that. So it's saying enter data, and it's waiting for me to enter data for this thing. So I'm going to say naught, naught. And hopefully, if this is working, it's gone and put naught, naught in here. That's my first point. 10, minus 10, 5, 7, 2, 2, 0, minus 1,000. Yeah. Now, from the way we've printed it out, it looks pretty ugly for a number of reasons. Let's fix this. So I might make the printout, oh, that's not the printout, it's reading it in. I might make the printout a bit nicer so I can see the points better. Let's try it again. Okay, that looks a bit better, maybe too many spaces, but that's a little bit better. So what's happened is, as I'm typing them in, each scanf is reading in 2 things at a time and storing it in the one index at the X and the Y field. So then the 10 minus 10 would be entered into here. The 5, 7 gets entered into the next one when I is equal to 2, I is equal to 3, I is equal to 4. Okay. Are there any questions about this? Does this make any sense? I know this is probably a bit tough. Does anyone have any questions? All right. All right, we'll just do one thing because we do have a little bit of time before the break. Let's move all the coordinates in this array by a constant value in the X direction. Now, this is a common thing to do. Like if you've got a bunch of data in a game or something, you might want to move it across the screen. So you might move it along in the X direction or something like that. Or by the same amount because you want the whole object to move as one, even though it's made up of lots of different, say, points. So how could we do this? Well, I'm going to need to pass in, I want to update all of them. I'm just going to call it move X. So maybe not the best name. So I'm passing in the size of the array, and I need to pass in the amount to move it by. So, you know, it could be move it by 10 units, whatever they are. Could be minus 10. It doesn't really matter. Let's try that. It shouldn't need to return anything. It should just go in and do stuff. And it should update this actual map. So let's go down here. So yeah, hopefully we're sort of getting into the habit of this. What are we going to do? How are we going to do this? We've got an array. We want to do something to every single element in it. What do we do? What do I start typing? So I will have by the time I've finished typing the data in, I'm going to have all of this data in here. Just say I've got 0, 0, 10 minus 10, 3, 1, 2, 2, 5, 3. I want to go through one by one, and I'm going to add on some amount. So let's imagine, so I don't have to hurt my brain too much, we're adding on 10 each time. So we go to the first element at index 0, we take this X coordinate and we add on 10. So 0 plus 10 gives me 10. We move to the next one, we take this X coordinate, it's 10, we add on 10, we're going to get 20, right? We move to the next one, we'll add on 10, just to the X part, we get 23. We move to the next one, we add on 10. Actually, what did I have before? Did I just get that wrong? I'm adding on 10, we get 12. I'm adding on 10, we get 15. I think I did 3 plus 10 gave me 23. I don't know. The code will do it better than that. So that's what we're trying to do. So we're still going through every item in the array, and we know how to do that with a while loop. So I'm just going to do my standard while loop. I'm starting at index 0, and I want to go up to I is less than the given size that I'm given. And I'm just going to go one by one. What am I going to do? Well, I need to go to each item. This is going to give me the element at the index I. What I want to change is the X field. So I'm going to get my struct and I'm going to go into the X field. And I want to This is like saying, give me a variable and add 10 to it. So I'm just saying, let's take this. Oh, well, it might not be 10. It can be whatever is in this variable here. So I'm adding on some integer amount to it. Okay, so I'm actually modifying it. So if this amount was 10, it'd go in and do all of the updates I just showed you, but it would do them correctly. All right, let's try it. And actually, sometimes when you're testing a program again and again, you get a little bit sick of typing in all the data, depending on how much debugging you're doing. So when the assignment comes out today, I'm pretty sure there'll be a section that gives you some tips on setting up data to use for it so you don't have to keep typing in the same data again and again. Okay, let's do this. Oh, now, the golden rule is I have to call the function. Let's do 10, just so we can tell if it's correct without straining our brains too much. Okay, so let's run it, and then we'll go on a break. That's better. 0, 0, 10 minus 10, 2, 2, 5, 4, 9, 9, that will do. Oh, gee, I need to print it out afterwards. One more time, and then I promise we'll have a break. Okay, 0, 0, 10 minus 10, 2, 2, whatever, whatever. Okay, let's just check. We had 0, 0, now we've got 0, 10. The 10's gone to 20, the 2's gone to 12. We've added 10 onto all of the x coordinates. It all seems to have worked. All right, so that's all we're really going to show you today in terms of arrays of structs, but you will be using them. It's structs just another type, so we can do anything with a struct really that we could do with an int, for example. So what's the time? It's about 5:02. We'll come back at about 5 past, and we'll talk about 2D arrays, or we can think of them as arrays of arrays. And this will be a really important topic for the assignment as well. So rest your brains nicely and come back in 5 past. versus who wants to do a quick Kahoot on 1D arrays? Hands up for 2D arrays. Hands up for Kahoot. All right, we'll do a very quick one. And the intention is to make sure that people are on top of the 1D array before I throw the 2D array at you. So there's some reasoning behind it. So are we back on? Yeah, okay, cool.
It's updating. That's fine. Are you happy to do the Kahoot, and then this will take like how long do you think?